Combinational loops are the loops that are formed in a circuit when the data starts and ends at the same point in a combinational path. Here is an example of a combinational feedback loop with a series of logic gates present in the path, and there is no sequential element in that path to hold the data. This might lead to unstable data output. Here are some of the impacts of having a combinational feedback loop in the design. It can cause unstable behavior in the data output, making it unpredictable due to large oscillations. Sometimes these loops may not significantly affect the simulation of the design using the EDA tools, but they can have a greater impact on the fabricated chip and may lead to functional failures. This type of combinational loop makes the timing sign-off critical. More switching or toggling within the loop can clearly increase dynamic power consumption. The combinational feedback loops are created in the design for many reasons. They are missing sequential elements in the feedback paths and only combinational logic are present, an incorrect use of blocking assignments in sequential logic within the RTL design, designing a finite state machine without using state registers. RTL design is still incomplete. Mismanagement of multi-driven nets and constant propagation logic. Inserting clock generation block without breaking loop paths. There are some of the best ways to prevent the creation of combinational loops in the design. These include inserting sequential elements into the loop, ensuring that there is a sequential element in the paths driven by clocks, and using features like linting in EDA tools, along with formal verification to check for unintentional or unintended loops. Here are some examples of combinational feedback loops. The first example is a simple feedback loop with an assignment statement where variable A is the not of variable B value, meaning variable A depends on variable B. Similarly, variable B is the not of variable A value, so variable B depends on variable A. This creates a loop between the two variables with no sequential element between them. The second example is the priority encoder with a feedback loop, which involves a loop between the variables mask and grant. The third example is a finite state machine with combinational logic. In this, the variable, state, is assigned to the next state without any register to store the value. This may create a loop between them due to the unavailability of a register to hold the state values across cycles. It might also lead to a logic error.